Imagine a world where we could turn back time. What if we could undo mistakes, relive cherished moments, or witness the world as it once was? The idea of traveling to the past has long captured human imagination, filling pages of science fiction and stirring endless philosophical debates. But as tantalizing as it may seem, there is a cold, unyielding law of the universe that renders this dream impossible: entropy. What is entropy, and why does it seem to hold the key to understanding why the past is forever out of reach? Can this fundamental law of physics explain why time flows forever forward and why it can never reverse? At its core, entropy is a measure of disorder or randomness in a system. Imagine a perfectly organized stack of blocks. If you knock them over, they scatter in a random, disordered heap. This scattered state represents higher entropy, compared to the low entropy of the organized stacked blocks. The universe, governed by the second law of thermodynamics, tells us that entropy always increases over time in isolated systems. But why does this matter for time travel? Entropy's relentless increase is what gives time its arrow, the unmistakable flow from the past to the present and to the future. Every moment that passes sees the universe moving toward greater disorder. A shattered glass, for instance, cannot reassemble itself on its own. A scrambled egg can't unscramble. These processes feel irreversible because they are irreversible. The law of entropy is what makes everything that happens in our universe permanent. You cannot undo what has been done. If time were to flow backward, entropy would have to decrease, meaning order would spontaneously reappear from chaos. But how could this ever happen in a universe where the laws of physics are so rigidly one-directional? This brings us to a fascinating question. Why does time seem to flow at all? The answer lies in the conditions of the universe itself. When the universe was born in the Big Bang, it began in a state of remarkably low entropy, a state of near-perfect order. Over billions of years, as stars formed, galaxies collided, and cosmic structures emerged, entropy increased. Every star burning its fuel, every planet cooling, and every moment of biological life contributes to the overall rise in disorder. Time flows forward because the universe started in an improbably ordered state, and entropy has been working ever since to undo that order. But could entropy be reversed? Could there ever be a way to lower entropy and, in doing so, turn the clock backward? On the surface, it seems theoretically plausible. If we had perfect knowledge of every particle in the universe and the ability to manipulate them, we might imagine a way to rebuild the past. But this is where entropy reveals its true power. The information required to reverse every process in the universe is so staggeringly vast that it's effectively unattainable. Even in hypothetical scenarios involving advanced technology or exotic physics, the sheer improbability of reducing entropy makes time reversal impossible. At its heart, entropy is tied to probabilities. There are far more ways for a system to be disordered than ordered. Think of a deck of cards. If you shuffle it randomly, the chances of the cards falling back into perfect numerical order are astronomically low. The same principle applies to the universe at large. The vast majority of possible states are the high-entropy disordered ones. The universe naturally tends toward these states because they are statistically favored. Reversing entropy would mean forcing the universe into one of those rare, low-entropy configurations, a statistical miracle on an unimaginable scale. One might ask, if the laws of physics are time-symmetric, meaning they work the same way whether time flows forward or backward, why does entropy only increase? This apparent contradiction has puzzled scientists and philosophers for centuries. The answer lies not in the laws themselves, but in the boundary conditions of the universe. Specifically, the extraordinarily low entropy starting point at the time of the Big Bang. It's this unique condition that set the arrow of time and dictated the direction of increasing entropy. In other words, the universe is like a clock that was wound up in the beginning, and it's been running down ever since. But what about hypothetical concepts like wormholes or exotic particles that could allow time travel? These ideas, while intriguing, face the same roadblock: entropy. Even if a wormhole could theoretically connect 2 points in spacetime, it could not circumvent the fundamental laws governing thermodynamics. Traveling to the past would still require reversing entropy and changing the state of every particle in the universe back to a former low entropy condition. Think about that for a moment. Every particle in the universe would need to revert back to a lower state of entropy and be in the exact same condition and state in relation to every other particle in the universe. It's simply impossible, because even if you were God and you had this power, you cannot just change the state of entropy in an isolated part of the universe. The arrow of time continues to march forward in one direction, indifferent to our dreams of breaking free from its grasp and traveling back in time. There's also the question of paradoxes, which often crops up in time travel discussions. Imagine going back in time and altering an event, preventing your own birth, for example. These paradoxes might seem like philosophical problems, but they are deeply tied to entropy. To rewrite the past would mean rewriting every interaction, every atom, every quantum particle involved in shaping that moment. The complexity of reversing all those processes, let alone avoiding the logical chaos of paradoxes, makes the idea of revisiting the past not just improbable, but nonsensical. So, what does entropy teach us about the nature of time and our place in the universe? It reveals that time is not an illusion or a human construct, but a deeply rooted feature of the cosmos, intrinsically tied to its fundamental laws. Time flows forward because entropy increases. The past is fixed because entropy has already unfolded in that direction. The dream of time travel, while endlessly fascinating, collides with the cold, hard reality of physics at every turn. Yet, there is something profoundly poetic about entropy. It is the force that drives change, the reason stars burn and galaxies evolve. It gives rise to life's fleeting beauty, as every living moment is part of the universe's gradual journey toward greater disorder. In a way, the impossibility of traveling to the past reminds us to cherish the present, to see it not as a fleeting accident, but as part of a grand, irreversible cosmic story. As we grapple with the idea that time is a one-way street, we are left with a haunting yet liberating truth that the past cannot be revisited and the future cannot be avoided. Entropy ensures that time flows in a single direction, a current that carries us ever forward. While the dream of undoing time may remain locked in the realm of fantasy, it is the reality of time's flow that shapes our lives, giving us purpose and urging us to create meaning within the finite boundaries of existence. In the end, perhaps it's not the ability to reverse time that matters, but the wisdom to understand and embrace the one-way journey that all of us are on. We thank you for joining us in our descent into the world of time and entropy, and we invite you back for our next episode,